today. Yesterday we looked at f of 3. And so what I thought I'd do is I would do f of negative 9 here with you guys, and then have you guys try f of 0. Let's remind ourselves of a couple of things here. So remember, the name of the function is the letter. Like in this case, the name of this function is f. In just a minute, you'll see other functions could be named other letters. The input is x, and the rule for this function is negative 5x plus 7. What that means is whatever the input is, we multiply it by negative 5 and then add 7.
Like the machine.
The machine. Mm-hmm. Exactly right. So this is our new machine yesterday. So this time, instead of plugging a negative 3 into our function machine like we did yesterday, we're going to plug a negative 9 in there. And so here's what that might look like. We would say f of negative 9 equals, I'm going to be plugging a negative 9 in wherever I see an x. So negative 9 goes right there, plus 7. But once you've plugged that input in, it's simply a matter of using order of operations to correctly evaluate. So what would be the first operation I would do on this one? Yeah, that's right, it'd be multiplication. So we'd say f of negative 9 is equal to 45 plus 7, because a negative times a negative is a positive. And then finally, maybe I could come over here and say then that f of negative 9 is equal to 52. So can we talk about what we won't do at this point? Say again?
Multiply f by negative 9.
Yeah, okay, because it's not multiplication. That's right. So because of that, what else won't I do? And therefore, I might be tempted to do what?
Divide by both sides.
Dividing, right? Because what a lot of people do here is they say, oh, I want to get the f by itself. You really can't, because it's not f times negative 9. It's just saying the name is f and the input is negative 9. So you would just stop right here and say that when the input is negative 9, the output is 52, and you're done. Nothing else to do with that. All right, will you guys please try f of 0? Why don't you try this with your table partner, see what you come up with for that one. All right, Deacon, can you explain to us what your first step was for this one? Deacon, can you explain?
Yeah. I filled in 0 to the lowest area to the right.
So tell me exactly what you wrote.
So I put a f and then 0 equals negative 5 and then like quotes.
Look at what I'm writing. Is that what you want me to write?
No, quotes 0.
What?
So like
Parentheses?
Parentheses. What did he say? Close?
Quotes. Quotations.
negative 5 and then parentheses x 0 in the parentheses and then plus 7.
Okay. So let's stop right there. We're going to need to keep going here. Deacon has got us off to a good start. Do you see how he has clearly replaced the x with a 0? Pretty clear step he's done there. All right, so from there, order of operations. Matt, what might that look like for you? We've plugged it in. What do we do with the order of operations?
You can multiply E0 times E5 and get 0. And then plus 7, so then that's like just change on 7.
Anything else?
Then go to the other side, do 0 times F, which is 0F, so 0.
Oh, so there's where you got to be careful. Did you hear that? He said on the left side we go 0 times f, which makes 0. That's exactly the thing we want to avoid. Let's be really careful with that. This notation right here does not mean f times 0. It simply means that the name of the function is f and the input is 0. I want to be super clear about this. That does not mean multiplication. It just means the name of the function is f, the input is 0. That's it. So there's no multiplication going on right there. It's simply name and input. That's it. So be really careful with that. Does that make sense?
So what does the final product look like? Just
Yeah, okay.
0 equals 7?
Great question. Yeah, so if we wanted to like tidy this up and make it a good presentation, we would say f of 0 equals 7. That right there would be a perfect presentation, just exactly what Rosie said. And the reason why that's such a great presentation is because you can clearly see three things. The name of the function is f, the input was 0, the output was 7. So in a lot of ways, this is better than the older notation that we used, where maybe at the end we would have ended up with like y equals 7. The reason why it's better is because here you can see the input. The input was 0, the output is 7. Before, if you had y equals 7, you'd be like, I see the output's 7, but what's the input? You'd have to go back up and look through the steps to see that. Here, it's like input, output. It's clearly stated. So that would be the best way. I agree. Great question. Anybody else with a question? All right, you guys are doing fantastic, but I think we should probably keep going with this, get a little bit more practice. What's coming up next here is, I think, a kind of a nice example of what might be expected on some quiz tests, standardized tests like the SAT or whatever, where you've got a couple of different functions. Notice now our function is not named f. There's two functions, right? One of them is called g, the other one is called h, whatever reason they did that. Both of them have an input of x. So you've got these two different functions mentioned here. We're supposed to find g of -8 and h of -3. So if you haven't already looked at these, please look at these and try these. These will operate really the same way as what you just did. You just have two different functions, so you want to keep them straight, like which one is which. Okay, so give it a shot, and we'll check your answer here in just a second. A good amount of time to do this, and I think Braden has inspired me to show you something sort of cool. Thanks for asking a good question. All right, here we go. So in A, it says we're talking about the g function. We're not talking about f or h. It does say g of -8. So that means for A, we are talking about this function right here. So that's the one I'm going to use. So g of -8 means make the input -8. So this would be 1 minus 6 times -8. The input for x is -8. So essentially all I've really done, I replaced any x's I saw with a -8. And we follow order of operations. -6 times -8 is positive 48. So that would be 1 plus 48. We know that 1 plus 48 is 49. So a nice presentation of the answer would be g of -8 is equal to 49. And we're done. Good?
Yes.
Okay. And then h of -3. So this means we are no longer talking about g. We are talking about h, which is over here. What's interesting about h, perhaps, is that aren't there two different x's within the rule for the function? So we're supposed to find h of -3. So I'm going to write h of -3 equals, make sure you use parentheses here, -3 cubed minus -3 squared plus 8. These parentheses are going to be really important because we're about to square a negative. As you guys remember, whether the parentheses are there or not makes a big difference. So here we go. Order of operations says I need to do the exponents before I do anything else. So -3 cubed is -27 minus, what is -3 inside the parentheses squared? 9. That's right. But wasn't that minus that was here? The minus that was here is still there. So it's always tempting to like multiply that minus sign in there. Oh, so Sarah, yep. Let's talk about that. That's really tempting to think that, Sarah, right? But if you say, think about this. If you say a negative or like a minus is a plus, you're doing multiplication. You're saying a negative times a negative is a positive, right? And if you do that before you do the exponents, you're going out of order of operation. You're doing PEMDAS instead of PEMDAS, right? It doesn't sound as good as PEMDAS. Okay, so plus 8. Sarah, you said, oh, wait, and then, okay. You got that. Okay, so then -27 minus 9 is -36 plus 8. Our final answer would be h of -3 equals -28. Notice how at the end I did not do any division. Did I mess something up? No? It's okay.
I got it.
Okay, cool. So, as mentioned before, these would be nice presentations of your answer, showing name of function, input, and then equals the output. Hey, can I show you what potentially, for those of you that have graphing calculators, can I show you a potential little shortcut? Wait, I will. So check this out. I got to switch screens on you a little bit. Do here is do the second one, the h of -3. I'll show you how you could have done this on your calculator. We'll talk about the work you got to show. If you know how to use your graphing calculator, the work you need to show is going to be sort of minimal. So this is kind of a cool thing. Here's how we would do this. Let's remember, you got it on your paper. Let's remember what h of x is, okay? Here is what we would do. And this is being recorded, by the way, so if you want to look at this again later, you're welcome to it. Do you guys see the red button I just pushed? No. Do you see the button that is red in the upper left-hand corner? Well, it's not red, it's y equals. It's only red because I pushed it. So any button I push, like the last button I pushed, will be red. So it's the y equals, and you should get to some screen that looks like this. I've obviously got some stuff in there. I'm going to clear all that out. There we go. So does everybody that has a graphing calculator, are you on that screen right there?
Yes.
So here's how you do this. We are going to enter h of x. I'm going to enter it into my y1 equation, just as it is, right? It's x cubed. Can you get on the right page here? Or sorry, I'm just trying to remember what it is. It's x cubed minus x squared plus 8. So check this out. X cubed. Oh, so sorry. I went too fast. Guys, I apologize. I'm used to going really fast with this. Do you see the green button? Look at on your calculator. Do you see how the button to the right of the green button says X, T, and then some Greek letter, then an N?
Yeah.
Push that button and an X will show up. That's what you want to use. Please, for goodness sake, do not use alpha X. No good. Don't do that. Push. It's actually one button push instead of two, so it's better. So you guys push the red button. We good? This is really useful. I hope that you'll catch on to this. Okay, so and then you see the caret over here. I'm using the mouse to. Oh, you can't see the mouse. The button that's about to turn red is the caret button. Do you see it? That means to the. So it's right above the division. So it should show up as an exponent now. So x to the 3. Those of you using your calculators, is this still good? Yeah. Okay. And then once you do that, you see how you're still in the exponent? You need to arrow to the right to get out of the exponent. Because otherwise it'll just keep writing stuff in the exponent, and we don't want that. So then we're going to go minus, Hano, is that right? Minus x squared?
Yeah.
So I went minus and I pushed the x button again. Do you guys see how diagonal from the 7 it says x squared?
Oh, is it okay if you just did it with the caret?
That's fine. But do you see how diagonal from the 7 it just says x squared? That's actually kind of a handy button because that will just automatically square whatever you just wrote. So x cubed minus x squared, and was it plus 8?
Yes.
Plus 8. Okay, so at this point, those of you that are working with your graphing calculators, have you been able to input that into your y1 equals? Okay, so let's remember where we put that. We put that into the y1 equation. Okay, this is our h of x. Your calculator doesn't have h's. There might be some way of programming that, but it's easier just to make it y1.
On the test, will it be a G and a H or different letters?
Could be whatever, G, H, F. Those are the most common. You have to do what?
You have to memorize the equation for me.
No, so I always have to tell you what it is. So, like you see G and H right here, I've just made those rules up. On your test, I might have G of x equals something entirely different.
Oh, yeah.
So these are not the same rules for all time. This is just for this particular question.
I was saying like the letter at the beginning.
Yeah, it could be GFH. Those are the most common ones, but it could be whatever. Okay, calculator people, you're going to like this, I think. Please, hey, especially those of you that are not doing the calculator, you need to be really respectful for the next couple minutes and just be quiet so that others can get this. We need to quit out of this screen. Do you remember, like, if you ever don't like the screen you're in, just push blue mode. You see how above mode it says quit? So I'm going to quit out of this. So I'm going to go blue mode.
Where's the second?
It's right next to the blue button.
Oh, I see it.
It's the one that's red.
You look at the one that's red. That's the last button I push. So
why do we do all that?
no, you got to push blue mode.
Oh no.
Blue.
It's right on
It's the second. It's this there. It's this one.
Pretty sure it's the only button that's blue.
I definitely messed with
Blue mode.
Yeah, so now I just messed
Blue mode. Oh goodness, what in the world? There we go. You pushed blue, I pushed it again. That's what messed it up.
Not nice.
Is it really like inside areas?
Looks like this. Graphing functions. I want to point out some things to you. I think will be very helpful. Please understand that when it comes to graphing, you see something like this, g of x equals 3x minus 2. The g of x is going to function just like the y. So if you really wanted to, you could think of this as simply y equals 3x minus 2. And that would really be fine. It's going to process the same way. And so let's just remind ourselves, you can think of this as a little bit of quiz practice for Monday. What kind of form is that equation in right now?
Slope intercept.
Slope intercept. Braden, what is the slope? Yeah, but sometimes it's good to write it as 3 over 1, but if you just said 3, of course, that is fine. And then we need to also identify the y-intercept. Julia, what is the y-intercept for this one? -2, that's right. So if we wanted to, we could write it as 0, -2. Same thing. Might be a little better description. So when we graph these, Jack, do we start by graphing the slope first, or do we graph the y-intercept first? It's actually the other one. We start by graphing the y-intercept first because we know that that point is actually on the line. We don't know exactly where to start the slope. So we're going to put 0, -2 on the graph. We know for sure that that is a point that's on our line, and then we count off our slope. Our slope is 3 over 1, as mentioned before. So what we want to do is we want to show our slope triangle, up 3, right 1. There's a point. That's a point right there. And maybe we do it one more time, up 3, right 1. There's a point there. Of course, you could always go the other way, right? The other way would be down 3, left 1, and that would put a point right there. In any case, how many points do you really need? Got to have 2. I put 4 just to make sure I got everything figured out. So then once you've done that, please always connect your points that are on the line with a line. So here's my attempt at that. Not too bad. And then finally, with this, because it's a function, do I need to consider dotted, solid, and shading?
No.
Why don't I need to consider dotted, solid, or shading? It's okay, so it's slope intercept form, but come on. It's not an inequality. It's an equality, right? It's an equation. So there's no need for shading or dotted or solid because there's no inequality. Do you guys get that?
Yes.
Every now and then somebody will go off on a wild tangent, start shading an equation. Should only shade inequalities. Wild tangent, that's right. Hey, we guys try number 6 with your table partner. Ready, set, go. Cha-ching. Kenzie, what form is this line currently in?
Not slope form yet. Right? Is it not slope intercept form yet?
You're saying it is or it isn't?
It's not yet?
I think it is in slope intercept form. If you wanted to, you could rewrite the f of x as a y because those two will function the same way. It's just different notation. Okay, so if it is in slope intercept form, we need to be able to pick out the slope and the y-intercept. Kenzie, what is the y-intercept on this one? Okay, so the y-intercept is 4. I will often write that as 0, 4. So there's that. That's definitely good. So then, Ashley, what is the slope for this one? The slope is 1 over 2. Jack, I'm coming back to you on this one. We've got our y-intercept, we got our slope. Which one do we graph first, the y-intercept or the slope? Jack? Y-intercept first, that's right. So 0, 4. So 0, 4 is right about there. And then our slope is 1 over 2. So that means up 1, right 2. So we go up 1, right 2. Or we could go down 1, left 2, something along those lines. Gives us a couple of additional points right there and right there. And then we try to connect those points with a good straight line. That is going to be my intent here. That looks okay. Put arrows on the end of it, and that would be my line. Again, thinking forward to your quiz on Monday, if you're ever going to use slope-intercept form, or for that matter, point-slope form, if you're counting off a slope, please use little dotted lines or little lines to indicate that you're doing your little slope triangle. So you see the red lines up there? You see them?
Yeah.
On a quiz on Monday, if you did something like this, I'd be looking for those red lines, or whatever color they were for you. I'd be looking for those little slope marks. If you're going to do them?
If you don't do them, is it a point off?
Absolutely. I want to see that you know how to count off slope. Make it show up. Scratch it in there. Yeah. It should be doable. Okay. You guys, this would come full circle all the way back to things that are distracting. Let's not do that. I know you have lots of excuses to be distracted, but please don't. Let's go full circle all the way back to what we talked about at the start of this lesson. We defined a function. Let's see if you guys can do that again today. A function is a relationship where every single input has exactly one output, exactly one. And so there is a way that you can test that out using a graph, and the way that you do that is called the vertical line test. Okay? Everybody make a vertical line with your arm. Vertical line. Right? So a vertical line would look something like this, right? Straight up. Okay? I'm sorry. Yep, you got your coat on. I get it. All right.
But it's if
So you can put your arms down. So here is, I want to explain something, so it needs to be quiet so I can have some sense that you're listening. If a vertical line intersects a graph in more than one point or more than one spot, then the graph is not a function. So if a vertical line intersects the graph in more than one point, then the graph is not the graph of a function. So let me give you an example. With A, I'm going to draw in a vertical line. I'm just going to draw it in right here. And what I'm going to do is I'm going to think about that vertical line moving across my graph. I'm just going to move it to the right. Sorry, Morgan?
How would you have a vertical line that intersects at 2 points?
Let me show you. So do you see I drew my vertical line in there, and do you see my arrow? I'm going to move it to the right. And I'm going to analyze it at each spot. So let's say that I analyzed it right here. Do you see how, if I put a vertical line right there, do you see how that vertical line would intersect my graph in 2 places?
Oh, okay, but not like on that. Never mind. I got confused, but I got it.
So right here, also, my vertical line would intersect the red graph in 2 places. So wouldn't it be fair to say that at almost every x value along this graph, won't my vertical line hit the graph in 2 spots?
Not a
Therefore, Sarah's conclusion is right on the money, not a function. So, would you guys please try to use the vertical line test to analyze B and C and come to a conclusion as to whether yes it is or no it's not a function. Please do that with numbers or letters B and C. So B and C, if you think about a vertical line roaming around on B, just kind of moving back and forth, there is a vertical line. Oops, that's not very vertical.
It's not a function.
It is not a function.
Wait a minute, I'm listening to you guys. Sarah, are you saying that the B is not a function?
Just kidding. It is because it was X line.
Do you see how no matter where I draw a vertical line,
Yes.
no matter where I draw a vertical line on B, it will only intersect the function or the graph in one spot, right? There's no way for me to get my vertical line in B to intersect the graph in more than one place. So yes, it is a function. And C is a little bit on the tricky side because if you put a vertical line right there, do you see how it intersects the graph in no spots?
Yes.
And then right there, let's say, again, intersects the graph in no spots at all. But then as soon as you get to x equals 2, let me try that again. As soon as you get to x equals 2, close enough, do you see how it intersects the line in all of the points on the line? So how many points are on a line? Infinitely many. Therefore, it intersects the line in more than one spot, right? So it's 2 plus whatever forever up towards infinity. So the answer for C is no.
I was wrong on
Not a function. Does it make sense now, though?
Yeah.
You're learning, right? So
It's not that it intersects the graph, it's the thing that's in the graph.
it's the graph. Yeah, because the graph is a vertical line. So
Because like this, like when I was saying like the graph, I thought you meant like the actual like x and y intersect. But it's
when I say the graph, I mean the graph of, because the x and y axis are always there, right? They're there 100% of the time. So we're talking about the thing that has been graphed.
Okay, got it.
Yeah.
I'm kind of confused.
Chapter 4 is all about systems of equations, so I want you guys to remember what systems of equations are, so listen carefully. Systems of equations, simply this, more than one equation. So if I were to say, what is a system of equations, you would say?
More than one equation.
There you go. What is a system of equations? It is simply more than one equation. Believe it or not, you could have a system of like 3 or 5 or 6 or 8 or 10 or 20 or 70 equations. I mean, you could have really an unlimited number of equations that would contribute to a system. We're only going to go with 2, all right? Because that's a good place to start. And as a matter of fact, if we had that many, we'd use a different method entirely. Okay, so the first little blank here, it says, when 2 or more equations with the same variables are considered at the same time, they form a system of equations. That's right, so that's some vocabulary. We're going to start off, as we typically do, trying to decide how to check an answer. How is it, we've done this, I think this is our 4th time doing this. How is it that you check an answer to determine whether it really is a solution or not? You always plug in, right? You always plug in. So number 1 says, determine whether 5, -1 is a solution to that system. And you can see in the system there's 2 equations, right? There's 2 simultaneous equations sitting there. And so in order for 5, -1 to be a solution to the system, it needs to make both equations true. So if it doesn't work in one of the equations, it's automatically not a solution to the whole system. So let's plug in, as you suggested, 2 times, well, is x the 5 or is x the -1? 5, right? Because it's x comma y, just like we typically do. So 2 times 5 plus -1 possibly equals 11. We just follow order of operations here. 2 times 5 is 10. And what's 10 plus -1? Whoa, okay. What does this mean?
No.
Okay, I'm waiting.
It's not.
So 9 is not 11. 9 is not equal to 11. Therefore, we could say 5 -1 is not a solution. Okay. So we only had to check one of them because the first one we tried, it did not work. So that means it's not a solution to the system. And we've done that, like I said, this is at least the 4th time in class we've done that. Is this making sense?
Yeah.
Awesome. Okay, this next piece is going to be particularly useful as you think about our quiz on Monday. Take a look at number 2. I want to do this one with you, and then I'll have you at least do this next one on your own. So this says, solve the system by graphing. And I'm going to leave you a little bit in the dark as to what this means. We'll get it figured out here in a second. But it does say to use graphing, doesn't it? So let's start graphing. Let's take a look at that first line. I'm going to make my first line blue. This line right here, what form is that right now? Is that like slope-intercept form, or is it something different? You want to make it into slope-intercept form?
Yeah.
Okay, so Sarah, how would you make it into slope-intercept form?
Subtract x.
That is right. So my first line, my blue line, would be y equals -x minus 4. Well, I subtracted it. Or you could do -4 minus x. That's fine. Okay. So let's pick this apart. Hano, what is the y-intercept for my blue line? 0, -4. Good. So let's see here. That's right here. And then I will do my little slope triangle thing. What is my slope? Slope is, it's -1x, right? So -1. So that means down 1, right 1, or up 1, left 1. So here's my little slope marks like that. I've got points at all of those. It does look like some stairs. Okay. So guys, there are all my points. There's my line. This is good review, right? This is something you need to be really good at for Monday, so hopefully this is helpful. The other line I'm going to use red. So, right there. How about that? Is that in slope-intercept form right now? It's not.
Absolutely not.
Colby, how do we get to slope-intercept form with the red line?
You would subtract, or you'd add, wait, you divide, no, you subtract x
All right.
from both sides, and then you get, negative y, and then equals 2 minus x.
You add.
Hey, Colby had a few stops and starts, but he got it right. He got it right. Colby, we'll give you a chance to redeem yourself. What else would you do?
And then you divide by negative 2 on both sides.
Man, you guys picking up on this? I hope you're really, really good at this. You're going to need to be really good at this on Monday. So, those of you maybe worked ahead, did you get this?
Yes.
Y equals -1 plus 1/2 x. All right, Kyle, we need to graph the y-intercept first. Yes, sir. Hold on. Hold that thought, Kyle. Braden.
Can we do this in the calculator, like, because it's both?
I will eventually show you how to use the calculator on this. Yes, I definitely will. Kyle, got to graph the y-intercept first. What is the y-intercept? 0, -1. Hey guys, come on. Let's finish strong. Finish strong. There's the y-intercept. Kyle's right. Keep going, Kyle. What's the slope?
You go up 1 and right 2.
So up 1, right 2. Couldn't we also go down 1, left 2?
Yeah, if you really want.
And I kind of think we really do. So check this out. We good? Hey guys, we're about to kind of hit the payoff moment here about what this is all about. Please, you should not be packing up. Oh, you have to go for what? Can you stick around for another 60 seconds? Because this is it right here. You don't want to miss this. Okay, so if I were to connect those points, but I not get that. So here's the key to the whole thing. Whenever you have a system of equations, the solution to the system is where the two lines cross. It's where the two lines intersect. So when you look at this graph right here, it's actually pretty straightforward, the way that the slopes and everything worked out. Where do these two lines cross? What would be the coordinates?
-2,
I think it's -2, -2. Does that make sense? So what you would say here is that this point right here is -2, -2. It's where the two lines cross. It's where they intersect. The solution to a system is always where the two lines cross. So our answer to the system, it says solve the system. The answer is -2, -2. It's where the two lines cross. Make sense? Now, I don't know why everybody's packing up. I realize Zaire has football. Do you have football too, Ashley? Okay. So I want you guys to try number 3 on your own. Please try number 3 on your own.
I don't understand how to do this.
Hey, guys. Hey, listen up, please. Ladies and gentlemen. I want to fill you in here before we go. The purple line has a y-intercept of 0 and a slope of 1/2. So I'm just doing this kind of quickly here. This line, whoops, this line would look about like this. Now the other line is not in slope-intercept form, but I want you to notice something. If I subtract x, I get -2y equals -x plus 4. Dividing by -2, I get this, positive 1/2 x minus 2. If I were to graph that line, I'll graph that one in red. The y-intercept is -2, and the slope is 1/2. I want you to notice this pattern. What kind of lines are these?
Parallel lines.
So when will they intersect?
Never.
So the answer to this one is no solution. We'll explore that more later on. See you for your quiz on Monday. Happy weekend.